All right, so this lesson is not technically in your textbook. It's because your textbook assumes that you already know how to do all of these things, which I don't know that you have seen very much. So we're going to do just a mini little lesson on how to simplify square roots to keep exact square roots. So we're talking about without a calculator. You might have to use one to divide some things, but we're not going to be getting any decimal answers. And then also defining what imaginary numbers are. And usually when I first say that, Algebra 2 students are like, imaginary numbers, what does that even mean? Like, I just get to make them up? I don't understand. So remember when you normally say, like, well, not normally, but in the past, you've said something like all real numbers. And for a minute, you're like, I guess right now you probably just take that for granted, but there's a reason that you say real is because there's a set of numbers that are real. And those are the numbers that you know about right now, right? Like 2 and -8 and 2/3 and 4.628, blah, blah, blah. Pi is a real number. The square root of 7 is a real number. Literally any number that you ever heard of, those are real numbers. That's why you've heard of them. Imaginary numbers are not numbers that you make up, but they are defined having to do with square roots. So you can go ahead and list these out for yourself as real numbers. And then we're going to take a break and come back to imaginary. First, I want to talk to you about just breaking down square roots. So perfect squares, these are some numbers that you need to have memorized. So I'm going to go ahead and make the list. I'm going to pause the video and make the list, and then you can do the same. Now, I'm going to be honest with you. If it were me, I would probably list these in the margin of my notes. So I wouldn't make like 3 columns. I just couldn't fit it very well on this screen. This is, and you might even have to list next to it for yourself. This is 1 squared, 2 squared, 3 squared, 4 squared. You need to have memorized all the way through 15. So most of these you should know already. We used them when we did difference of squares, but you need to make sure you know these because we're going to be using them. Okay, so we're going to do 4 quick examples, really 6. There's 2 more on the next slide. But they're going to go super fast. So square root of 9, if it's a perfect square, you already know what it is. The square root of 9 is 3. Done. That's all you do. That's the answer. Some of them are not perfect squares, though. For instance, 72 is not in my list. And in middle school, you might have like estimated around where that was. I don't care about an estimate. In algebra, I want to know an exact answer. So if you try to type that in your calculator, it's going to give you a decimal, which again is not an exact answer. So what our goal is to think about what's a perfect number that goes into 72. And so the first time I do this problem, I'm actually going to pretend like you don't know what the perfect number is, okay? This is going to be the long method. So let's say that you know 9 goes into 72, and that's 9 times 8. So the first thing I'm doing is I'm rewriting this as multiplication. Square root of 9 times the square root of 8. I put the perfect square first, so that's important. You may want to make a note of that. Make sure the perfect square is the first number listed. And then I'm actually going to evaluate that. Well, the square root of 9 is 3, and I don't know the square root of 8, so it's just square root of 8. Now, here's the thing. This is not all the way broken down because there's actually another perfect square number hiding inside of 8. And hopefully it doesn't take you too long to realize that that square root number is 4. So I'm going to write this as 3 times the square root of 4 times the square root of 2. Okay, so this 3 is just coming down. Let me show you. This 3 is just falling down, and then the 8 is splitting to become the 4 and the 2. Now, the square root of 4 is 2. The square root of 2 is just the square root of 2, and then 3 is out here. So I'm going to multiply 3 times 2, and this is going to give me 6 square root 2. And the reason I know that's the final answer is because 2 does not have any perfect square roots inside of it, so we can't break that down anymore. Now, there was a shorter way. If you didn't know that there was a bigger perfect square, there is one. There's a bigger perfect square that goes into 72, and it's 36. 36 times 2 gives you 72. And I know the square root of 36 is 6, so this is 6 square root 2. I'm showing you both of those because there will be, obviously you want to try to get the biggest one right away, but there will be plenty of times when you can't get the biggest one for whatever reason. It's a crazy number, you just aren't thinking, about it at the time, whatever. So you need to recognize that if it's not if this number still has something perfect in it, you're not finished. All right, let me do one more, and I'm actually going to change this last example. All right, so now that we've got that fixed, let's do the square root of 160. So hopefully that one doesn't take you too long to realize the perfect number is 16, and 16 times 10 gives me 160. So 16, I know the square root of that is 4, and this is 10. Now, you always, like I said before, you always want to ask yourself, can that break down any further? And sometimes people like try to take the square root of this number again. It doesn't have a square root symbol on it, so don't keep taking the square root. And then in this one, sometimes people think, oh, well, 10, I can break 10 down into 2 and 5. But neither one of those are perfect squares. In fact, the only numbers that could potentially go in, 1, 4, and 9, those are the only perfect squares, and none of them go into 10, which means this right here is your final answer. There's nothing else you can do. Usually like write that this is, okay, so this is where our little imaginary friends come from. In the past, if you, and even if like in your calculator, if you try to type this in your calculator, it's gonna say error, non-real answer, and your calculator's not lying to you. It's not a real answer, it's an imaginary answer. And the reason has to do with the fact that you've got this negative inside the square root. Because think about that. A square root, right? The square root of 9 equals 3 because 3 times 3 equals 9, right? Well, the issue with the square root of negative 9 is I can't come up with any two numbers that multiply them by themselves and give me a negative number, because the only way to do that is have a positive times a negative, and by squares, they have to be the same. So because we can't do that, we define a number as imaginary. So we're going to define the square root of negative 1 to be what we call an imaginary number, I. Okay? It is a number. It's not a variable. You can't solve for it. But it's also not quite like pi, because you can't like type it in and kind of calculate with it quite the same way. So let me show you how we break these down. I would maybe write this down for yourself, and then I'm going to erase that. Okay, so this is then the square root of 9 times the square root of negative 1. We already said the square root of 9 was 3, and the square root of negative 1 is I. So this square root of negative 9 equals 3i. If we do the square root of 50, so this is the square root of 25. I always like to write some, in the past I usually, sorry y'all, I keep hitting the wrong thing. I usually write the I above it just so we don't forget. So this is square root of 25. You can write negative 1 in here, or just remember that there's an I on the top, and then square root of 2. Okay, so I'm not sure how you want to do that. I don't know what is the best way to teach you, since I'm not going to see you face to face. But let's make this, I'm just going to write the I at the top. All right, square root of 2. So square root of 25 is 5. Square root of 2 is 2. Square root of 2. And in that I, we're just going to sneak right here. It has to be in the answer because there's a negative there. And I just thought of one more example that I need to show you, and I'll make this super fast. If I can zoom. Okay, so let me show you one that looks very similar but is not the same. If it says negative square root of 9, this time the negative is on the outside. So if the negative is on the outside, that is not I. It's only I if you're trying to take the square root of a negative number. So the square root here, this would be negative, and the square root of 9 is 3. So that would be negative 3. It's probably important that you see those two examples compared to one another.